Hello, 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 hello. Hello, 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 hello. Hi, everyone. Okay, funny story. So I accidentally meant to pause the recording, but I actually just stopped it altogether. So this video will be in two parts. So we're going to talk about radicals and rationalization right now. So the idea with radicals is that there's these square roots that we typically find annoying in mathematics, and it's going to become apparent that we're going to have to do a lot of these manipulations with them and just how to get rid of them and how to what's appropriate and what's not appropriate. So first with radicals, the idea of plus or minus, they're still factorable regardless if you're adding two of them or subtracting two of them. But the gimmick is that if they're radicals or if they're like you can even treat it as like an unknown variable x, right? If I have k x's and c x's, as you see right here, I could just, combine that count of x's. But instead of saying x's, you say, that square roots. So you're allowed to do that. Um, the square root, like how it's related to powers, is also distributable. So if you take square root of a fraction, you take the square root of the top part and the bottom part individually. You don't have to do this all the time, but it's one of those things where like if it helps, right? Or if it not if it helps, I should say if it makes your problem more legible. Similar things happening here. The square roots, we know that that is combinable under multiplication only. So if you do, for example, here I'm gonna write it here. If I do square root of a plus square root of b, that does not equal square root of a plus b. Please keep that in mind. And then you have square roots, they cancel each other out. If you I shouldn't say they cancel each other out, but this, is a simple trick where it becomes the square root squared, which that cancels each other out, and that's left with a. Okay. All right, next is rationalization. We don't like radicals and denominators, right? And there's going to be a lot of problems because we're dividing by expressions often, and we will make sure that we're not dividing by zero. So like, there's just a bunch of reasons I could list on why we need to know this trick of rationalization. So the way we do it is we multiply that square root on the bottom and the top, right? This is just a glorified multiplying by 1. And we know anything multiplied by 1 is still going to be that anything. But instead of writing 1, you just write that square root. So, for example, here we see that if I multiply this by square root of 3 over square root of 3, that's going to be 5 square root of 3 over square root of 3 times square root of 3, which just comes out to a 3. Now, even when something is added or subtracted to the radical, we multiply it by the conjugate to go ahead and eliminate the radical from the denominator. Now, this doesn't get rid of the radical entirely, but if the trick is we need to get rid of the radical on the denominator, then you can go ahead and do that. Sometimes you also need to get rid of it on the top of a fraction. I don't remember if we see this trick in our class, but it could happen. So either way, the whole point is that if you see an entry plus the radical, you need to multiply it by the entry minus the radical and vice versa. So for example here, if the task is to rationalize this, we need to multiply this by 1. But instead of saying 1, we say we're multiplying the whole thing by 2 plus the square root of x minus 4 over 2 plus the square root of x minus 4. Then here, what happens is a distribution. So let's do, here, I'm going to do it piece by piece first. 8x, 2 plus that square root expression over 2 minus square root of x minus 4, 2 plus square root of x minus 4. Okay. Hold on, give me a second. Okay, cool. All right. So then we distribute. We got 8 times 2. That's going to be 16. We got x times 2, that's going to be 2x. And then we got 8 times that square root, so it just literally becomes 8 square root of x minus 4. And then we got x times that square root, so plus x square root of x minus 4. All over 4, because 2 times 2. And then minus, parentheses, x minus 4, since it canceled out. And then I don't know why I did it out of order. Here, let me um, let me color code just a little bit so we make sure that what's happening is happening correctly. Okay. So, I don't know if we have enough space, but we're definitely going to try to make it better. 8 times 2, that became the 16. And then x times 2, that became the 2x. And then we got 8 times that square root, that became this. And then x times that square root, and that became this. Okay. And then for the bottom, I jumped to these two first. I don't know why I did that. But we can still, do it anyway. We got, what is it here? I'll try to keep the colors the same. 2 and 2, that became 4. And then, let's see, I used green for that. So these guys and these guys, that became this. And then you have, 2 times that square root. So 2 square root of x minus 4. And then the purple, which is just the insides, which is minus 2 square root of x minus 4. And for that, it's easy to see that these will cancel out, and you're also able to simplify the bottom a little bit. Let me do that in steps though. So we have 16 plus 2x, and then let's go ahead and factor out that square root. And then that cancels out, and we're left with 4 minus x plus 4. And that just became 8. So 16 plus 2x plus 8 or x plus 8 square root of x minus 4 all over negative x plus 8. Okay. A little weird looking, right? But definitely not out of place. All right. Let's go ahead and rationalize this guy next. So this guy, again, multiplying it by 1. Oh, an important thing is that the argument inside that square root never changed here. That looks like a 9, but it's a 4. So just keep that in mind in case. Our habit is, as we keep rewriting these square roots, we may accidentally lose that they're inside the square roots. So just keep that in mind. I say that and watch, I'm gonna fall for that trick I said too. Hopefully I don't, but we'll see. And I have the square root of x plus 2 over the square root of x plus 2. Okay. Here it's a bit easier to manage. We got 6 plus 3 square root of x. And here, I'm just going to go ahead and use the difference of squares idea, basically. And we got x minus 4. And there you go. That's your answer there. All right. The last thing that we want to do is just reiterate function input and output. Now, there's the technicality of using a numeric value that we start you guys off with when you first are learning the subject, but then later we increase the difficulty to letters, and then we increase the difficulty to letters that are expressions. So we're gonna do first the base, where we're going to ask you, oh, let me read this just in case. A function is a rule that assigns one output y for each input x. When you replace an x value, do the replacement in parentheses, especially if it's a negative value. Use the parentheses in your calculator as well. Okay, so for example here, we want to first take this value, because we're going to plug in -2. We're going to go ahead, every instance we see an x, we're going to replace it with parentheses. So, and we use x because that's what they use here to notate it. So I see blank blank squared for that x squared minus 4 and make that blank. And then the next step is that we fill it in with -2. So -2 squared minus 4, -2. Go ahead and follow PEMDAS like you normally would. That's going to be 4. -4 times -2, it's going to be plus 8. And then that's going to be 12. How about over here, where this time we're doing x plus h? Okay. Well, like I said before, go ahead and place every instance of x with a set of parentheses. So I have negative parentheses squared minus 2 parentheses plus 3. No parentheses here. There's not an x. It's just going to be plus 3 at the very end. And I'm going to go ahead and plug it in with x plus h. So negative parentheses x plus h squared minus 2 parentheses x plus h, close, and then plus 3. From here, we're going to do some simplifications and get this out of the way. We got a negative parentheses x squared plus 2xh plus h squared minus 2. Oh, wait. Yeah, I'll distribute later. Or I'll distribute right now. Now I'm going to distribute the negative and that -2. So we have negative x squared, negative 2xh, negative h squared, minus 2x minus h plus 3. I don't see anything I can combine. There's no common factors among any of this. So that's as simple as I'm going to get. The last one now is use the solution from example 2 to find f of x plus h minus f of x. Now we're going to see this a lot, where we're going to have to manipulate these expressions within these notations. So keep in mind we define f of x plus h. We define f of x plus h as negative x squared minus 2xh minus h squared minus 2x minus 2h. Oh, I didn't write a 2 here, my mistake. Make sure you write that 2 there. And then plus 3. Then minus f of x. So that's going to be minus all of that f of x, which we had defined as negative x squared minus 2x plus 3. So that's going to be double negative situations going on. Let's go ahead and do that. I'm just going to take a beat to rewrite everything on this side. And then go and distribute that negative. So we got plus x squared. We got plus 2x. And then we got minus 3. So there's going to be some things we can cancel out now. We can cancel out this guy with this guy. We could then cancel out this guy with this guy. And then we can go ahead and cancel out this guy and this guy. And we're left with this expression, negative 2xh minus h squared minus 2h. Okay. A little weird, but a valid expression to get. All right. Now, recap with the visual aspect of a function. On a graph, an open circle means we cannot be that y value. A closed circle means we can be that y value. If there is no closed circle or function keys at desired x value, then that f of x is undefined. So let's go ahead and go through these. f of x where x is -5. Okay, so we look at the x here. This is our x-axis, our y-axis, and we look for -5, and we see that our function line does exist right here, and that's going to go ahead and be a 5. Actually, let me color code this just so I can make sure that we are following along. Okay. Then we have -3, so I go -3, and I see two pieces where our function line lies in, but I see an open circle and a closed circle. Remember, we said open circle cannot be that y value. The closed circle means it can. So that means I should go down here and mark this answer as -5 instead. Okay. And then let's start here next. Or here, let me pick some more. Okay, then we go -2. -2 has a similar instance with the open and closed circle, but I go here with the closed circle, so it's going to be 4. All right, then here we have 0. 0's actually kind of cut plain here. It's going to be 0 as well. Okay. Um, then we have 2. 2 has two instances of open circles. So which one do I pick? Trick question. You don't pick any. At the end of the day, it cannot be where the open circle is. So that means it is undefined. All right, and then the last one, or here, let me see which color haven't I used. I haven't used this red, I believe. The last one is 4. 4 is 1. Hang up. All right, pretty straightforward. We can go ahead and boost the difficulty just a little bit. So now we're going to go ahead and use this function graph. Wait. Um, Let me see. I think I forgot the labeling on these. What did I have as the labeling? Let me see real quick. Um, oh, this is g of x. Okay. Um, mm, I think I think I made a typo here. Let's go ahead and let me just double check something real quick. I want to say, yeah, the typo I made is that this line doesn't exist. So let's go ahead and Y out that line. And that's f of x and that's g of x. Okay, sorry about that. Do I have use I have g of x. Okay. All right. So f of x reads that first we take f of -5, which we got there as 5, and then minus g of -3. So we look here, g of -3. Um, and g of -3 is going to be -2. So 5 minus a -2. And that's going to be 5 plus 2, 7. G of -1 is next, and g of -1 does not exist. Well, I guess it did at one point, but we're going to go ahead and call that undefined. And then we have g of 2. So g of 2 actually just has that weird point of being -4. And then lastly, f of -3, which we clocked as -5 from earlier, and g of 2, which we clocked as -4. Or actually, let me write plus -4. That's going to be -5 minus 4, and that's going to be -9. And that's our answers. Okay. Sorry about that typo. My mistake. I'll try to upload the corrected version for you guys in a moment. But that is gonna be it for this review. Let me just double check everything. Trying to see if I missed anything. I want to say here. Oh, I did miss something here. Okay, let's talk about it. So I accidentally made that negative a plus here. So let's go ahead and talk about what that affected. So let's see. Okay, so anywhere that X went, which is the purple and the green, that's going to get a negative in front of it. And then over here, that's technically an easy typo to fix because I can just draw a negative right here. And then that becomes another typo to fix. Yeah, because I see what I meant to do here. Um, let's see. So after that, what you should see here is that you can factor out 2. So you'll get 2 parentheses 8 minus x. Here, I forgot to put the negative. Plus negative 8x plus 8 square root of x minus 4 over negative x plus 8. And we can factor out all of these x minus 8s and a negative x plus 8s. This is technically the same thing as this, but I just happen to rewrite it differently. So we can cancel all this out, and we're left with a 2 here, and we're left with plus square root of x minus 4. And now that is our answer. Okay. The ink dried, so let me just reiterate that that was supposed to be a negative, so that's negative x times 2, which is negative 2x, and then negative x times that square root, so that's negative x times that square root, and then in factoring it, we see that that's negative x plus an 8, and then that still be negative, that still is negative, and then, yes, okay, all right, uh, let's see, sorry about that, yeah, okay. Um, that's all I really wanted to talk about today. Um, Now don't forget, after this video, maybe you take a breather, you take a beat around, but I want you to print out the worksheet that I'm going to be posting, and then from the worksheet, you can either do it on your own, or you can do it along with me. Maybe for this first one, you do it on your own. That's fine. I'm not gonna be too picky about that. But at one point, you should start doing them on your own and then playing the worksheet video and seeing how you fare. All right. Again, let me know if you have any questions, and I will see you in the next video. Bye, everyone.